This question is related to moment or turning on the pivot. For a boat to maintain a constant upright position in water, the weight which is acting downward and the upthrust should be same or balanced. The weight act through point G, and this that is the center of the mass of the boat, and U, the upthrust force, is acting through X, the center of a gravity of volume of water displaced by the boat. G and X are shown in the diagram. So as you can see the position of G and X. A sudden gust of a wind applies a force on the sideways of a boat and cause it to tilt. The line of action of a W and U move apart distance D, like the distance between them is D. Explain the effect of the moment UD. So what will be the effect of the moment U and D? So as you can see here, like the point of the rotation, this is a point around weight is acting downward. This one is X. So this force U is there and the distance D. So which direction it will cause a moment or a turning effect? This is a force and acting at a distance D. If G is the point of rotation around which the object rotates, so what will happen or what is the effect of this force? So it will cause an anti-clockwise movement. For example, if I have an object which is fixed from one end and there's a force acting upward at a distance D. So which direction this force will cause a moment or a turning effect? That will be anti-clockwise. So same thing happened. The force will cause an anti-clockwise moment. So force U is there and a distance. So moment is a product of force and distance. So U into D. And what about the moment caused by W here? That will be zero. Why it will be zero? Because it is acting on the pivot. So if I have a pivot or a point of rotation and a force is acting on the pivot, so the moment is a product of force and distance. There is a force, but the distance from the pivot is zero. So the turning effect is 0 Newton meter. So this W is having a turning effect 0 Newton meter. And if this F is having a moment or a turning effect, F into U into D, upthrust into D. And what is the direction? The direction is anti-clock. So anti-clockwise is U into D, and the clockwise moment is 0 Newton meter. So as a result, what will happen? This boat will rotate, like it will be cause an anti-clockwise rotation, or it will return back to the same original position. That is what happened in case of a sudden gust or the air exerting a force cause a boat to tilt, then the boat will return back to the same original position. So there will be a moment, anti-clockwise moment will be there, but the clockwise is 0 about point G, and as a result, what happened? The boat will return back to its initial position and it will reduce the tilt. So in this part, explain what would happen to the boat in windy weather if a center of the gravity is higher. So what will happen if the center of the gravity is higher? Like this was a boat and the value of the G is higher here. As compared to the initial position. So if G is higher, look, this was D and the upthrust U was acting, the weight is acting down. But as G is higher, the distance between them, the distance R is decreased. So if the distance D will be reduced. So U is upthrust, D is reduced. So what will happen? It will be U into D. U is not changing, but D decreases. As the center of the gravity is higher, the distance D is shorter. As a result of a distance D is shorter, because U into D is causing an anti-clockwise moment. So this anti-clockwise moment, this is the anti-clockwise moment, the moment which is causing it to move in anti-clockwise direction. This is point G. So when we compare, check the figure. So as I mentioned in the second part, what will happen if the center of the gravity is higher? So you can see if we increase the center of the gravity, like this is the first position, but now this one is the center of the gravity. So if the center of the gravity is raised, because it can move along this line, center of gravity. So the distance decreases. This is causing an anti-clockwise moment. And now weight is also, like as the center of the gravity is raised, the weight was acting. Now there is a distance, the component of the weight is there, and U is also acting. So as a result, what will happen? This one is U, like this one is the center of the gravity. Center of the gravity is G and this one is U. And the distance D is there as U is raised. So the distance D between the center of the gravity and U is decreased. As a result, when this distance decreases, what will happen to the anti-clockwise moment? The anti-clockwise moment will decrease as well. So if the anti-clockwise moment is not sufficient to balance the wind speed, so as a result, what happened? Because as the air is blowing, this air apply a force on the boat and it is trying to cause a clockwise moment. But that clockwise moment was originally balanced by the upthrust and it was higher value. But if the upthrust is not, if the moment of due to the upthrust decreases, because the distance decreases, so as a result, what might happen? The boat might topple or boat might tilt further clockwise. So the air is causing a force on the boat and it is trying to cause a clockwise moment. But that is balanced by the upthrust, which is acting upward, that causes an anti-clockwise. But as a result, what happens if the center of the gravity is raised? The anti-clockwise moment, which is a product of U into D, D is decreasing, so anti-clockwise moment will decrease. So the air might topple this boat. So in short, you can say the U into D anti-clockwise moment will decrease. Why this decrease? Because D is decreasing. So and the clockwise moment due to the force of air and the force on the air, force on the boat due to the air is causing a clockwise moment, because this anti-clockwise moment is responsible for the boat to return back to the same original position. But if it's a too high wind speed, more force is there, so the boat will topple. And in part B, some boats use the ballast tank, which is refillable tank in the base to improve the stability. So as you can see, when the ballast tank is empty and when it is filled, it changes the position. Explained why the position of X for a ship when it has a full tank is lower than the ship when it is empty. So what is the reason for that? Basically, the position of a center of mass or center of the gravity depend on the distribution of the mass. So when it is filled with the water, it will have a greater weight, and that time basically the weight is more than the upthrust, so that's why it will go down, move downward. That's why the center of the gravity will decrease. So upthrust, and when upthrust is equals to the weight, the upthrust increases, so the boat will float. And as a boat is moving downward in water, so the center of the gravity of displaced water, because center of the gravity of a displaced water is X. Two things are there. One is the center of the gravity of the boat. The other one is the center of the gravity of the displaced water. So when it is filled, when the tank is filled, it will displace, the more water will be displaced, because like more it is go inside, greater amount is inside, so as a result, like greater volume is inside, so more water will be displaced, so the volume of a displaced water increases. If the volume of a displaced water will increase, so the upthrust will also increase. So upthrust is equals to density, gravity, and depth. So G is actually representing the center of the gravity of the board, and U is representing, X is representing the center of the gravity of the displaced water. So as a result, what will happen? So when filled with water, the weight or the mass of a boat will increase. And when mass will increase, so U is equals to, when it is, as you can see, it is filled with water, so mass or a weight will increase, and weight is equals to upthrust. So here the second, when it is deep, so it have more weight, or you can say it has a greater upthrust, and upthrust is equals to density of a fluid, volume of object, and gravity. The upthrust is equals to density into volume of a displaced gravity. So as a result, when upthrust will increase, the volume of a displace will also increases. So as greater volume will be displaced, so center of a gravity of a displaced water will be lower. Like as you can see here, that this part, this was X initially, and this is a new position of X. And what about the weight? Because of more distribution of the center of the gravity of the board, why it is lower when it is filled with water? Because more mass is there at the bottom, so greater the mass, like more particles are at the bottom, that's why the center of the gravity is lowered. And what happened to the value of the X also, you can see here, volume of a displaced liquid. So the volume of a displaced liquid is represented by X. So when it is filled with water, the weight of our mass increases. As a result, the upthrust will also increase. And because the boat is floating, so upthrust must balance with the weight. And as the boat moves downward in water, the volume of a displaced liquid will also increase. So center of the gravity of a displaced water is lower.